It turns out the ratio of your waist to height is the key determinant of how many years you're going to live. So, for example, if you have a 42-inch waist and you're 70 inches tall, 5'10", your ratio of your waist to height is 42 divided by 70, or 0.6. And scientists have done a lot of research on different people with different waist to height ratios, male and female, ages 30, 50, and 70, and come up with equations to predict how many years of life you'll lose as a function of your waist to height ratio. So, for example, if you're a male 30 years old, the number of years you would lose of life based on your ratio would be 616.67 times the ratio of cubed minus 920 times the ratio squared plus 467.83 times the ratio minus 81. And there's an equation for males 50, males 70, females 30, females 50, females 70, and we've used range names throughout this here, as you'll see. And so the question would be, if I would type in a given age for a male or a female, how many years of life would they lose? Well, if it's 30 years old, you would just plug in this formula, which we put right here for each of the ages 30, 50, and 70 in males and females. But what happens if your age is not 30? For instance, if your age is 36, what would you do? Well, you look over here, 36, you have to sort of interpolate between 30 and 50. Well, you're closer to 30, so you should give more weight to the 30-year-old equation than the 50-year-old equation. Now, how do you figure that out? Well, basically, you're 14 years out of 20 away from 50. That's 70%. So you give 70% of the weight to 30 and 30% of the weight to 50. And so you can see right here what I did. If you're 36, you take 50 minus 36 divided by the distance between these years. That's 14 over 20. 70% of the weight would go to 30. And then basically 36 minus 30, 6 over 20, 30% of the weight would go to 50. And a similar equation holds between 50 and 70. Like if you're 56, you would give 70% of the weight to 50 and 30% to 70, etc. So the question is, how do we implement this with formulas? I should note that this example comes from a great new book I bought and read, The Calculus of Happiness by Princeton University Press, 2017, by Oscar Fernandez. Okay, so I put the ratio here of the waist to the height for the males and the females. Let's suppose it's 0.6 for both. Okay, then I put a 36-year-old male here, a 44-year-old female, and so we should get 70% of the weight in our interpolation for the male comes from 30, 30% from 50, and for the female it should be the opposite, and no weight comes from 70. So the trick is, how did I do this? And then compute the final interpolation here. Okay, well, I did if statements. Okay, so basically, you know, a person could be under 30 or over 70, and then you shouldn't really use these equations because you have no data for people under 30 and over 70. So if the age of the male is less than 30 or the age of the male is greater than 70, I put the word none here. Now, if the age of the male is less than or equal to 50, I put this formula. You took 50 minus the age of the male divided by 20. Otherwise, you're in a case where the person's over 50. You wouldn't use the 30-year-old in your prediction for how many years of life lost. Now, for female, it's the same thing, except you just key off the age of female. Okay, now what do you do for the 50-year-old? It's a little trickier because whatever the age is, anywhere between 30 and 70, you'll use the 50-year-old calculation to get the years lost. So 50 years old, again, if you're under 30 or over 70, put the word none there because we don't know. Now, if the person's less than 50, less or equal to 50, which means they're not less than 30 or greater than 70, that means they'd be between 30 and 50, you would use this age of the male minus 30 over 20. And otherwise, if they're not less or equal to 50, they're in the age group 51 through 70, you'd use this formula here, 70 minus the age over 20. So like if they're 56, you'd use 70% of the weight would go to the 50-year-old equation. Okay, so we've got that done there. Now here for the females, it's the same thing, but do age females. Now what about for the 70, basically how much weight do we give the 70-year-old equation? Well, if they're less than 30 or greater than 70, we still have none. If they're less than or equal to 50, we have a 0 because we don't give it any weight. Otherwise, we would do the age of the male minus 50. For instance, if the person was 66, we'd give 80% of the weight to 70 years old because 66 would be sort of 80% of the way from 50 to 70. Okay, you can see these weights work here. So if I put a 36-year-old here, I get 70% of the weight to 30, 30% to 50. 44-year-old, 30% of the weight to 30, 70% to 50. Now, how do I put it all together? New function may be a sum of product function. Sum of product takes a row times a row or a column times a column. I think we've mentioned it in some other videos, which you may or may not have watched. If you watch our videos on the solver, you'll see much more on sum of product. But the equation here would be, if there's a none here, then basically, then we put can't tell because we really don't have a good prediction. Otherwise, for the man, we would multiply these three predicted years lost, 30, 50, and 70, times the respective weights. Okay? And we would do the same for female. If there's a none here, then their age is outside the range we can predict. Otherwise, you sum a product, okay, the weights here times the female equations, which are in row 7, 8, and 9. So to see if this works, like if I would put a 36-year-old, I get 1.6. Okay, now that's much closer to the 30-year-old prediction than the 50-year-old prediction. Now for a 44-year-old female, I get 1.129, and that's basically closer to the 50-year-old, which it should be. Now if I put somebody in here who's under, let's say, 25, then I get you can't tell, okay, which is just what I want. So we've used range names, sum of product function, and if statements to basically do a sort of fairly complex interpolation.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.